Hello everyone, my name is Sourena Maroofi from University of Grenoble, Alpes. I'm doing my PhD under the supervision of Maciej, Korczynski and Andrzej Duda. I'm going to present our paper, COMAR, Classification of Compromised versus Maliciously Registered Domains. This work has been carried out in the framework of COMAR project funded by AFNIC, the Registry of FR domains, and SIDN, the Registry of NL domains. So let's start with an overview of DNS Reputation Systems. Proposed DNS Reputation Systems are able to detect malicious domains using different techniques at different phases. For example, Predator is able to detect malicious domains at the time of registration. It can be used by registries, and as soon as the domain is registered, it can label it as benign or malicious. Another example is Exposure, which classifies domains based on the activity, mostly based on passive DNS features. All of these systems classify domains as either malicious or benign, without considering a third case, which is compromised domains. Compromised domains are domains which are originally benign, but get compromised and misused by attackers. But why we need to distinguish compromised domains? Well, compromised domains have also legitimate traffic that we don't want to block, so we should not treat them like malicious domains. Therefore, the mitigation action for compromised domains is different from malicious ones. In case of malicious domains, we can block the domain at the registrar level, or delist the domain at registry level, or even suspend the host at hosting providers. But doing the same action for compromised domains probably cause financial loss because of the legitimate service that these domains offer. Another reason to distinguish compromised domains is to create a more effective domain blacklist feed, which gives us a better insight into attackers' behavior. Current blacklists like OpenFish contain both malicious and compromised domains without distinction. For example, based on the latest anti-phishing working group report, by the end of 2019, 74% of all phishing websites were using TLS. What does it mean? Does it mean that attackers tend to use TLS for their maliciously registered domains more than before? Or they tend to host their phishing pages on compromised domains, and those compromised domains tend to use TLS more than before? We can only be clear about that if we exactly know which domains are completely malicious and which are compromised. If we have a blacklist purely consists of malicious domains, then we can extract patterns from attackers' behavior. Otherwise, we cannot be sure about the statistics and patterns we extract from public feeds like OpenFish, since there is no distinction for domains which have been registered by attackers and domains which have been compromised. Let's see an example of compromised versus maliciously registered domains. The image shows the structure of two websites, a compromised one on the left and a maliciously registered domain on the right. The structure has been extracted by COMAR data collector module. The blue nodes in both graphs are the phishing pages uploaded by attackers. Both of these websites have been taken down by their hosting providers. Well, this takedown decision is probably appropriate for the malicious one, but for the compromised website with more than 100 benign pages and only one malicious URL doesn't seem to be the right decision. So our contributions are as follows. We developed COMAR, a system to classify domains exhibiting malicious behavior as either compromised or maliciously registered by only using publicly available and readily accessible resources, and achieve 97% accuracy with 2.5% of false positives. We leveraged 38 features to identify the state of a domain, 14 of which are completely new and have not been used in previous work. We introduce a new method to estimate the domain creation time in case there is no access to whois information, which outperforms the standard statistical methods in filling missing values. We show that content-based features are the most important ones in representing the domain status. This is the overview of our system. The input of our system is the malicious URL, and the output of the system is a label for the underlying domain, either as malicious or compromised. The data collector module is responsible for collecting data. In the feature extractor module, we extract 38 features to be used by the classifier. And finally, the classifier module, which label the domain as compromised or malicious. We implemented 38 features in 7 different categories. Each category has several features. We divided the features in several categories to make it easy for the end user to remove specific feature sets if they don't have access to the data. For example, to make COMAR completely practical, by only using publicly available data, one can exclude passive and active DNS features which are extracted from third-party providers. We designed COMAR in a way to be completely practical. In practice, there are always some difficulties regarding feature collection. Whenever we talk about extracting features, we need to also consider missing values for features. If we cannot collect data, we cannot classify domains, or even worse, we misclassify them. As an example of common missing feature is domain registration date, which can be extracted from whois data. Unfortunately, some TLDs do not provide registration date as part of whois data, so here we have a missing value. Another example is content-based features. What if we cannot fetch the content of the website? The technique to compensate missing values for each feature is different. For example, for the domain registration date, we use the following approach to estimate the registration date if we cannot extract it from whois data. We get the oldest date that the domain has been seen in either Wayback Machine, Certificate Transparency Log, or passive DNS data. Of course, considering some constraint to make sure that the domain is not a drop-catching one. We show that for approximately 70% of the samples, the difference between the true registration date and our estimated value is less than 1 year. While, for example, for mathematical mean and median approaches, this value is less than 25%. Regarding ground truth dataset, during 2 months, we manually labeled 2,300 domains from 4 blacklist feeds and used 2 machine learning approaches, logistic regression and random forest. We compared our method with the simple method used in APWG report. This table shows the accuracy of our method compared to APWG method for phishing and malware dataset using random forest and logistic regression. As you can see, the accuracy of APWG method is 85%. Although it's less than the accuracy of our method, which is 97%, still it's not bad considering the fact that they just used 3 simple heuristics. But looking at the false positive, meaning detecting maliciously registered domain as compromised, the false positive of APWG method is 26% compared to our method, which is only 2.5%. This figure shows the classification results for phishing and malware datasets, removing one feature set at a time. As you can see, by removing content-based features, the accuracy of the classifier drops, and we can see the increase in the classification error in both datasets. On the other hand, removing other feature sets do not affect the classifier results heavily. COMAR leverages publicly available data and make classification decision based on the extracted features. Registries, registrars, and hosting providers can use it to decide on appropriate mitigation actions for each domain with malicious content. It can also serve as an effective tool for creating domain blacklists from the existing URL ones. We showed that the content-based features are the most effective in capturing the amount of benignness of domain during their life cycles. We introduced a new technique to compensate missing values in the domain registration date field of the whois data that outperform the existing methods. Thank you for your attention.